Welcome back everyone. In this tutorial we are going to study normal distribution. This lecture could be the most important lecture in this course because all the next lectures are mainly dependent on normal distribution. Gaussian distribution is another name for normal distribution, and there is another name also which is bell-shaped distribution, because when the data are perfectly normally distributed, you will see the shape of a bell. So as I said, the normal distribution is the most important probability distribution in statistics, and that's for several reasons. First, it fits many natural phenomena and case studies. And the second important reason is distribution of sample means with big enough sizes could be normally distributed. So in this chart, we have a standard perfect normal distribution. Mean in normal distribution equals 0. If you look at this curve, you will see that mean or mu is in the middle on 0 and standard deviation equal 1. So if you go to the right side, you will find the standard deviation equal 1. And also, if you go to the left, you will see the standard deviation is 1 also because it is minus 1. And the absolute value of minus 1 is 1. And the third important characteristics here is mean equal median equal mode. Mean is the highest value in the normal distribution. And you see other data are dispersed perfectly in a symmetrical way around the mean. So it's perfectly symmetrical on the right side and the left side of the mean. And because the data are equally dispersed on the left and right side of the mean, you don't see any skewness. So there is no skewness in the standard normal distribution. Let's have a look at these charts where we got different scenarios for normal distribution. In this scenario, mean differs, but standard deviation stays constant. So if you look here, you will see the mean here equal 2 and the mean here equal minus 2. However, the standard deviation still equal 1, and that's why the bell shape stays the same in both cases, because we still have the same standard deviation, the same width. We cannot see any difference in the shape. The only difference here is the whole data shifted to the right in the first chart and shifted to the left in this chart. And here we have another example where mean constant but standard deviation differs. So that's why you don't see the curve move from its location. It stays in the same location. However, you find the width keep changing because the standard deviation is different from case to case. So in the first case, when curve 1, the standard deviation is low. And in curve 2, standard deviation has been increased. So that's why you will see the curve is wider. And again, in curve 3, you will see a bigger standard deviation. And that's why the curve is the widest compared to the two previous scenarios. So this is an example when the mean stays constant and the standard deviation differs. And here we have several scenarios when the mean and the standard deviation are different. For example, the one in the middle with the blue curve, you have mean 0 and standard deviation 1. So this is the perfect normal distribution. And in the red curve, you'll see the mean equal 2. So the curve shifted to the right because the mean is 2. And we got a smaller standard deviation, which is half. So that's why we got a narrower or tighter curve in this case. And the last scenario here in the left, in the green curve, mean equal minus 2. That's why the curve shifted to the left. And the standard deviation equal 2. So that's why we have a wide curve here. So when we got the scenario of non-perfect normal distribution, and we need our data to be perfectly normally distributed. So we want to convert this curve and this curve to be like the blue curve in the middle, which is the standard normal distribution. What is the method to do that? We call this method standardization. And we are going to learn this method in the next tutorial.